So, good afternoon. My name is Khalil Klouche. I'm from Helsinki Institute for Information Technology. And today my talk is about our work improving the experience of exploratory search on touch devices. It is well known that most search activities go well beyond a simple lookup search, and we describe as exploratory any search activity in which we engage without having a clear goal in mind. As an example, you can see me here getting information on what to do while I'm in Seoul and eventually wanting to get inspired by the kind of food I'd be able to taste here. There are several query reformulation until I find some good articles with nice photos. I also save interesting web pages into multiple tabs, and at some point, you'll see it in a minute, at some point I want to use the name of a Korean dish that I want to investigate. I want to use it as a query, but since the spelling is hard for me to memorize, I have to select it on the touch device, which is rather difficult, and then I copy-paste it as a query. So you can see me struggle a little bit by when trying to select that word. So let me skip the end of the video. This was one very, very fast example of how search can be performed on traditional tools using a touch device. You could see that it was part browsing and part querying. And while browsing is very adapted to touch devices, query formulation is never trivial, but it becomes even more difficult on touch devices. Also, interesting information gets hidden within tabs, and you have to remember that it exists somewhere to be able to reuse it. We have identified some challenges that are common to many search tasks on surfaces. First, exploratory search requires the user to frequently reformulate the query in an area she's not necessarily familiar with. How do we find new search directions without having to go through long lists of results with low quality information, because that would slow down the iterative process of query reformulation, and also it breaks the fluidity of the exploration. And finally, text entry on touch devices is not yet on par with their physical counterparts, mouse and keyboards. It's slower, more error-prone, which also impairs the fluidity of the experience. To tackle these challenges, we decided to take a design approach, which ultimately led to the design and development of Exploration Wall, which is a novel user interface and a system for exploratory search that is adapted to multi-touch interaction. I'll walk you through the interface. The workspace is pretty simple. You have two areas. You have the query area at the bottom, which is grayish, and the result area on top, which is the big blue part. To start a search, you simply tap in the query area to enter the topic of your search. Let's type information retrieval, and it creates an entity. Right now, it's of the keyword type, and it's represented as an object that can be dragged around. This entity will serve as a query, and the system, based on that query, will return a set of results. You can see the results are composed of more entities of different types, all related to information retrieval. You have documents in the upper part. They are the brown icons. They can be browsed. Also, you have, in that case, authors, that's the red icon, and more keywords, that's the blue icons. Other dataset could require more types like places or events or even time periods and other examples. Those entities are ordered by type and by relevance, with the most relevant entity at the top. That vertical structure is something that we call a search stream. From a search stream, you can take any entity and drag it down to the query area. As you can see here, we drag a document, and that document, that article, serves as a query to get a new set of results. So you see that the system has returned entities that are related to the document, and you can also see that we have now a parallel search stream that allows you to visualize several sets of results simultaneously. You can also flexibly reorganize the workspace by moving things around, and you can even make new streams based on composed queries. Like in here, you have two keywords that serve as one single query. Since they are close enough, they are considered as being one single query. So it's very flexible, and you can always scroll further as to get some more room for more streams. So there is no no limit on the horizontal space. Let me show you a little bit of exploration wall in action so you can see more features. You can see the user create an entity by typing down serious games, and in the results he can access to the content of a document by typing on the title. The content includes the abstract and some metadata like the authors and keywords. He can also save some elements into a reading list for later use and create more streams, etc. Let me skip the rest of the video, which is available online. Some benefits of this design is that Exploration Wall offers an alternative to text entry, and at the same time it provides ideas for queries reformulation. Also, having numerous queries allow the user to keep track of her search history, and it fosters connection between recent results and older results. But that's just me talking. At some point we had to properly evaluate the system. So we have conducted a study in order to understand the effect and implications of our design on search performance through a measure of effectiveness of the system, user search behavior, and usability and engagement. Here's a little summary of the experiment we made. We had two interfaces, Exploration Wall and Baseline that I will describe in a minute. And we had two tasks that were related to exploratory search, one short, 5 minutes, and one longer, 20-minute task. We had 10 subjects with at least a minimum experience in research. The document collection that we used was composed, in that case, of scientific literature from several sources. We decided to limit the data to scientific literature for two reasons. The first one is that scientific search tasks are suitable for scenarios where users' goals are uncertain and require exploratory search behavior. And also, the second reason is that experts were readily available for providing high-quality relevance assessments for the retrieved documents. Now, the baseline. It was implemented following the interface principles of traditional search tools. That is, a typed query and a result list of documents that are showed by their title with attached authors and keywords. It was crucial that the baseline displayed the exact same information to the user as Exploration Wall, so we made sure that the system uses the same document collection and also that the ranking is based on the same document retrieval model. The baseline was used in the browser, so participants had access to tabs for parallel browsing. Concerning our measures for effectiveness, what we did is we pooled all documents that were retrieved by all participants in both tasks and both interfaces. Then we had experts that have assessed each document as being either relevant or non-relevant. We used that data that was then computed to, that data was then used to compute standard performance indicators for information retrieval systems that are precision, recall, and F-measure. For search behavior, what we did, we logged the participants' action on both interfaces as to analyze their search trail. And finally, we got feedback on usability and engagement through standard questionnaires like SUS and UES. Concerning our results, regarding effectiveness, while we didn't get significant difference in the short task, we got very encouraging results in the long task. Here you can see the scores related to the baseline to exploration wall, and on the first line it concerns precision, which represents the fraction of all retrieved documents that were relevant. Precision indicates from the user's point of view how much relevant results he got from his queries. It's an important indicator since a low precision is very frustrating for the user. And here we got equal results with the baseline, which is not bad. And on the second line we have recall. Recall represents a fraction of all relevant documents that were retrieved, and this indicates how well participants have covered all available relevant information on a topic. And now we can see that exploration wall has more than double the score of the baseline. That indicates that more relevant documents were retrieved when using exploration wall, and that was very, very encouraging. And concerning the F measure combines both precision and recall to provide one number that assess the performance of the system. And again, we double the score of the baseline. So we were very happy with those results that clearly confirmed the validity of our design on a performance level. To explain that score in recall, we think we found some explanations into the analysis of the search trail and search behavior. Here what we did is that we logged the actions performed by participants, and we collected from those actions a few parameters that represent their search trails, like, for example, the number of queries that were made, the number of text entries per query, the number of branches, etc. For the long task, all parameters are favorable to exploration wall. For example, you have the number of text entries per query, which was expectable, but still most participants, 3 times out of 4, used drag and drop of entities to create a query instead of relying on text entry. Regarding number of branches, most participants really took advantage of the parallel search stream to branch and revisit previous results, while most participants performed a very linear search using the baseline. And with 0.7 query per minute on exploration wall against 0.26 on the baseline, participants showed much more active search behavior, which can explain the better coverage showed by the higher recall. In the short task, it shows less dramatic results, but still favorable with less text entry, more branches, more parallel queries, all using exploration wall, even within the 5 minutes of the session. Regarding usability and engagement, within the context of the task, users seem to actually like the features of exploration wall and seem to be more engaged and found it more usable than the baseline, since we got favorable results both on the SOS questionnaire and the UES. That was a nice indication that users actually found useful the features of exploration wall and didn't feel forced to use them. Exploratory search is difficult on touch devices with current interfaces. With exploration wall, we took a design-driven approach in addressing those problems. Exploration wall offers an alternative to text entry. It helps with query reformulation, and numerous parallel queries allow the user to keep track of the search history and fosters revisits and branching. To finish, I'd say that search is not linear, it's a highly dynamic activity, and considering the ever-growing popularity of touch device, we believe that our work offers a flexible and enticing template for designing user interfaces supporting information exploration. I'd like to thank my collaborators on that work, Tuukka, Ruotsalo, Diogo, Cabral, Salvatore, Andolina, Andrea, Bellucci, and Giulio, Jacucci, for their help on that work, and I'd like to thank you for your attention. Yes, I understand. Yeah. How could I answer this? I mean, exploration, as you said, exploratory research is iterative, but it still relies on the fact that during the iteration and during the while getting new information to identify new search directions, you make your choices based on relevant information and on things that relies to what you are looking for, or some expectations. So I think recall and that kind of search performance still has a role to play in that kind of systems.